Hello, and welcome to, this is going to be the first, actual full video demonstration for, well, I guess this school year. I've started doing these really late, but if I end up sending this to someone, it would be, just to help them out with this topic, which is RedOx, oxidation and reduction, for honors chemistry, of course. So, oxidation and reduction is pretty simple, but I'll go over it as we are going through. That's our first equation. Zinc plus a copper 2 ion yields a zinc 2 ion and copper. That's a very, very simple one. So because these two elements are alone, 0. Always. That's their oxidation number. That's, I guess, also kind of their chart. It's their oxidation number. That's what I'll say. For the not pure elements, their oxidation number is just this, switched around. So, plus 2, right? Write the oxidation number for each element below it. Okay, below it, I wrote it above it. Too bad. Blah, 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 blah. 688, no. Write the name or symbol of the element oxidized and the element reduced. Okay, we'll do that. Then write the substance from the reaction side that is the oxidizing agent and the reducing agent. Or, yeah. Blah, 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 blah. Okay, so it does not say we need to do anything about writing out the equation for it, but I'll write it out for this first one anyway. So because zinc is going from 0, right? And it's going to zinc 2 plus, that means that it has to go from 0 to being, positively charged. Which means that since it can't lose protons, otherwise it would not be zinc anymore, it has to lose electrons. Well, it can't gain protons. That would be how it would get positive without losing electrons, but no, it loses electrons. So we just write it out, plus 2e minus. That's electrons. This isn't a necessary step as far as I can tell, but it's good to know. Because for copper goes from 2 plus, let's give it some space, to just copper, which means it has to go from having a different amount of protons and electrons to having the same amount of protons and electrons. So, to give it that same amount of protons and electrons, we're just going to add 2 electrons, and that balances them again, right? Okay, oxidation. An easy way to remember oxidation, or I guess this is just I don't remember it this way, I just remember it because I remember it. That's how I remember things, but I'll give you this. Oxidation, imagine you have copper. Actually, copper oxidizes, that's a known one. But to go from, let's just say Cu2 plus, actually. Let's say we added an oxygen, which is 2 minus, right? This, well, it's going to lose charge, if you get what I mean. It's going to go from positive charge to negative charge, to neutral charge, which would be kind of losing charge. It's not losing electrons, it's actually kind of gaining them in a way, because it shares them with the, but you know what I mean. Its charge is getting lower, but instead this way, oxidizing is actually losing the electrons. So it's actually zinc that is oxidizing. So I guess you can ignore what I said about copper, because copper is reducing here. So we'll just write in zinc, right? Zn. Element reduced, it's just going to always be the other one. Whichever one you can identify better, go for that one. The other one's going to be the opposite. If you're better at telling reduction, that's your reduction. And then the other one's going to be oxidation. If you're better at telling oxidation, vice versa. There we go. Oxidizing agent. The oxidizing agent is not the one that oxidizes, because agent is meaning that it allows it to, which oxidizing something does not allow something else to oxidize. Because this is giving off electrons, and it's oxidizing, it allows this one to gain electrons, the same electrons, supposedly, and then it can reduce. So, zinc is the reducing agent, which means that copper is the oxidizing agent. It gains these electrons, which allows this to give off the electrons. So that's, That's the simple problem on here. It's not too hard. See? Let's do... Ooh, this one has multiple. So let's do this one. Maybe. Let me look it over first. Huh. Does it say we have to balance it? Okay, let's just go with this one, I guess. No. No, it's fine. This is a very basic way that can be applied to any of them, and it won't require me to work these out on camera, and it keeps this video at 6-ish minutes, which is easy. It's just an easier watch. So, I'll go over it very quickly again. Oxidation number for pure elements is 0. Oxidation number for anything with a charge is going to be just reversed, right? If it's an element ion, monatomic. But for something like this, oxygen usually is 2 minus, but this whole compound is also 2 minus, so it has to add to 2 minus, I believe. Is how that was. Hold on, I have instructions. I guess we have to balance it first to even know. Yeah, well, we need 2 of these and 2 of these, pretty much. To go from that to that and that to that. So the interesting part is that it doesn't really have oxidation, as far as I can tell. Because these two combined... Yeah. Well, I mean, if it's the person I'm sending it to, you have the same sheet. I'll just go over some of these rules. If it's not the same person, like it's just someone finding this, then you might not. Okay, right and balanced formula equation, which we have here. This one actually is balanced, but it's also just, it would, if it was unbalanced, like how this one was before I wrote in the twos. Okay. Assign oxidation numbers to each element. We did that, right? Split the equation into 2 smaller equations, an oxidation and reaction half. Oxidation. Reduction. Did I say reaction? Balance each half equation for any element that's not oxygen or hydrogen by adding coefficients. We did not need to do that for this one. Balance each half equation for oxygen by adding H2O to the side with fewer oxygens. So I'm guessing that's what this H is doing here for this question here. The question 4th one is that's for balancing somehow. Balance each half equation for charge by adding E minus to the side with more positive charge. We did that. Well, we did that one. Well, we did on both of these. The one with more positive charge. Remember, oxidation loses electrons, so it should be in the product. Oxidation. And reduction gains electrons, so it'll be a reactant, which reduction. Adjust the coefficients of the 2 half reactions so that the same number of electrons are gained in reduction as less than oxidation. 2 electrons, 2 electrons. For equations in basic solution only, add OH to both sides of the equation to cancel out any hydrogen ions remaining. The blah 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 blah. Okay, I don't think we really need too much to do that. For equations in basic solution only. Combine any ions removed in step 2 so the equation appears in the original formula equation. Check to ensure that... Okay, so it's basically like if you took out, let's say it was like zinc chloride or something somehow. I guess zinc chloride 2. Zinc chlorine 2, right? If this was oxidizing, then it would lose electrons, right? you just would write zinc still, I believe. Something like that. I don't know. I am not completely sure for this, but that's my way of, that's how I solve this. I guess as a disclaimer, I should say that I'm not some omnipotent, chemistry god, so obviously some of the things I said could have been wrong, but it's better than no one saying anything about it, Like, I mean, sure, people have said about it, but, this is another way to review, if you will. So, yeah, there was my take on RedOx.